projects. In this video, we are going to explain the project Blockchain-enabled fog resource access and granting. Introduction. This project focuses on enhancing fog services which encompass a set of computing and storage services. Fog services in this context are mobile servers that move virtually within a network, allowing users to connect to the nearest fog server for high-capacity storage and computation. These services enable efficient access to computing resources, data storage, and processing capabilities for users. Traditional methods like cloud and edge services often suffer from slow response times and centralized authentication, which pose security and service availability risks. To address the limitations of traditional methods, this project embraces decentralized blockchain storage. Blockchain is like a digital ledger that records transactions securely and transparently. Instead of having all the data in one place, blockchain stores records as blocks of data, each with a unique code called a hash. These blocks are distributed across multiple computers or nodes, making it much harder for anyone to tamper with the data or compromise the entire system. Blockchain offers several advantages. First, it is decentralized, meaning the data isn't stored in one vulnerable location. Second, it enhances security because the data is stored in encrypted format that is very difficult to alter or hack. Third, it promotes transparency as all transactions are recorded and visible to authorized users. Fourth, it ensures data immutability, meaning once something is recorded in the blockchain, it can't be easily changed. Finally, it is resilient to failures because even if some nodes go down, others continue to maintain the data. So, the project leverages Ethereum blockchain to deploy a smart contract that manages fog users' authentication. These smart contracts contain functions for handling user authentication and service access, simplifying user interactions. Objective of the project. So, as I mentioned earlier, the primary objective is to enhance fog services through blockchain integration, optimizing user authentication and resource access. Traditional cloud and edge services often struggle with slow response times and centralized authentication, posing security risks. This project seeks to create a responsive and secure fog service environment. By leveraging blockchain strengths such as decentralized data storage and tamper-proof security, the project aims to streamline the management of fog service authentications. Ethereum blockchain smart contracts are used to simplify and secure user authentication, ensuring a more user-friendly experience when accessing fog services. Fog service providers can list their offerings on blockchain, providing subscribers with a consistent and reliable authentication process. This allows users to access services from multiple providers without the need to manage complex authentication details. Requirements needed to execute this project are hardware requirements: processor of i5 and above, RAM of 8GB and above, ROM of 25GB and above. Software requirements needed are Node.js, Python 3.7.0 and Visual Studio Community version. To execute this project, we have designed few modules. The first module is new user sign up as service provider or subscriber. In this module, new users have the option to sign up as service providers or subscribers, allowing them to create their accounts and define their roles within the system. The second module is service provider login. Service providers can securely access their accounts through this module, enabling them to manage their fog resources, offerings, and subscribers effectively. This login process enhances the security of service provider interactions. The third module is publish fog resources and offers. Service providers use this module to list their fog resources and offerings on the platform. They can specify details such as cost and processing power, providing subscribers with transparent information for informed decisions. The next module is View Subscribers. Service providers benefit from this module as they can access a list of subscribers interested in their fog resources and offerings. This feature streamlines subscriber management and interaction for service providers. The next module is Subscriber Login. So, subscribers can log in using this module to access fog services securely. User authentication is a critical step to ensure that only authorized subscribers can utilize the services provided by fog service providers. The next module is Search and Purchase Fog Contract. So subscribers utilize this module to discover available fog service providers and complete contract purchases. This step is vital for subscribers to establish secure access to fog resources. The next module is access storage to upload data. So once authenticated, subscribers can use this module to access storage resources for secure data uploads. This functionality enables users to store their data on fog servers, enhancing data security. And the last module is download storage data. So subscribers can view and download their previously uploaded data through this module, facilitating easy access to stored data on fog servers. This feature simplifies data retrieval and ensures user data remains accessible. Blockchain integration. So blockchain technology is employed to manage fog service authentications. All user authentication data and access records for fog services are securely stored in the blockchain. Each record is saved as a separate block in the blockchain with a unique hash code associated with it. When new data is added, the blockchain system verifies the hash codes of all previous blocks. If any data has been tampered with or altered, the hash codes won't match, triggering a verification failure. This ensures the integrity of the stored data and makes it resistant to unauthorized changes. The Ethereum blockchain is utilized for its smart contract capabilities. Smart contracts contain authentication functions that validate user access to fog services, ensuring secure and efficient interactions between service providers and subscribers. Blockchain's distributed ledger system stores fog authentication data across multiple nodes, reducing the risk of data loss or service disruption if one node becomes unavailable. Data immutability and verification mechanisms enhance the overall security of fog service access. And fog service providers publish their services and offerings on the blockchain, allowing subscribers to select and subscribe to services without the need to manage authentication details for each provider. Blockchain simplifies and secures this authentication process, promoting a consistent and reliable user experience. Subscribers can securely upload, store, and retrieve data on fog servers through the blockchain, ensuring data integrity and access security. This blockchain-enabled data management system enhances user trust and reliability in fog services. Execution of the project. To execute this project, first we need to open the code folder which contains the project source code files. So this is fog folder. Inside this folder are Python code files that are intended to be dynamically loaded into the project during runtime. This is fog app folder. This folder comprises a static folder which contains files related to CSS, JavaScript, and Bootstrap. These files contribute to the visual and interactive aspects of the application. Fog app folder also contains a templates folder. Within this folder, we'll find all the HTML pages used throughout the project. It includes pages like index.html, home.html, and more, representing various sections of the website. And it also contains Python code files that will be executed during the runtime of the application, supporting its functionality. This is HelloEth folder. Inside this folder, I have a Node modules folder. So this folder consists of dependencies or modules needed for the project. Now open .bin folder. So this folder often contains executable scripts related to the project's dependencies. So here we can see a run blockchain.bat file. Double click on it to start the blockchain. So this script will initiate the local Ethereum blockchain for development purposes. It contains commands to start the blockchain environment. So now the blockchain is hosted on the local machine at the local host and port. So this address allows us to interact with the blockchain using various tools and applications. Now execute the command truffle space migrate to compile and deploy the smart contracts. I'm typing truffle space migrate and hit the enter button. So Truffle is a development framework for Ethereum that simplifies the process of compiling and deploying smart contracts. They are deployed on a blockchain network and can facilitate various transactions such as transferring tokens or managing digital assets. So once the migration process is complete, Truffle will provide us with a unique Ethereum contract address. So this is the contract address. This address represents the location of the deployed smart contract on the blockchain. And here we can see gas used. So to execute the Solidity file and compile smart contracts, this is the amount of gas consumed. Now minimize this, and this is Fog Contract SQL file. So this file consists of Solidity code. It handles data structures, functions and events with modifiers for validation. This is manage.py file. It is a command line utility that comes with Django. It provides various commands for managing Django projects, including tasks like running the development server, creating database tables, applying migrations and more. And this is run.bat file. Instead of executing the project through command line interface, we have created Windows bat file to execute the project. Now double click on it to start the Django application. So the Django framework will host the application locally at the default address at localhost and port unless configured differently. Now copy the local link provided by the framework. I am copying it and paste it into any web browser. I prefer Chrome. After pasting it, type index.html at the end and hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using the Django framework. So here we can see service provider login, subscriber login and new user sign up here links. So if you are new users, we have to register first. Click on new user sign up here link. Fill in all these details. The username is Ravi. Give the password, contact number, email ID, give the address, select the user type from the drop down. I'm giving it as service provider. Now click on register button. So in the blue color text we can see sign up process completed and record saved in blockchain. Now we'll log in. Click on service provider login link. Give the previously mentioned credentials, username and password. The username is Ravi. Give the correct password. Give the user type, that is service provider. Now click on login button. So we have logged in as service provider Ravi. Now click on publish Fog resources and offers link to add Fog services which subscribers will purchase. Fill in all these details. The Fog service name would be Google Fog Computers. Description is Fog services with 60 TB speed. RAM size is 64. Storage size would be 100 TB. Computing processor capacity would be CPU 5.0 headset. Cost would be $100. Validity is 1 year. Now click on submit button. So here we can see the Fog service details have been added to blockchain. Now click on view subscribers link. So here we can see there are no subscribers yet. Now click on logout. Now click on new user sign up here link again. Now we'll sign up as subscriber. The username would be Ram. Give the password. Give the contact number. Give the email ID. The address. Select the user type as subscriber. Now click on register button. So here we can see sign up process completed and record saved in blockchain. So all these details will be saved to blockchain. Now click on subscriber login link. Give the previously mentioned credentials, username and password. The username is Ram. Give the correct password. Select the user type as subscriber. Now click on login button. So we have logged in as subscriber Ram, and here we can see search and purchase Fog contract, access storage to upload data, download storage data and logout links. Click on search and purchase Fog contract link. So here we can see list of service providers, and we can see all the details, the service provider name, service name, description, RAM size, etc. And we can see a click here link. By clicking on it, we can subscribe to that particular service provider. So before subscription, if we try to click on access storage to upload data link, then we will get this error that authentication failed, subscribe to access storage. So now click on search and purchase Fog contract link. Click on click here link to subscribe. So here we can see purchase successful. Now click on access storage to upload data link. So here we can store any data at Fog. Click on choose file button. So I'm selecting this document. Now click on open. Now click on submit. So here we can see the provided document is saved at Fog storage. So now click on download storage data link. So here we can see the file name, the uploader name, and we can see a download data column in which I have click here link. By clicking on it, we can download the file from the Fog. I'm clicking on click here link. So we can see the file has been downloaded. Similarly, we can upload any file to Fog and can retrieve from the Fog. Now click on logout. Now we'll log in as service provider again. Click on service provider login link. Give the credentials, username and password. Select the user type as service provider. Now click on login. So we have logged in as service provider Ravi. Now click on view subscribers link. So here we can view list of all subscribers. We can see all the details, company username, Fog service name, subscriber name, contact number, email ID, address, subscribe date. Now click on logout. So the conclusion here is, by incorporating blockchain technology, user authentication and access to Fog services have become more efficient and secure. This improvement ensures a smoother user experience. Users can now easily and securely interact with service providers, leading to a more reliable service environment. This streamlined approach ensures dependable services. The tamper-proof nature of blockchain technology ensures the safety of user data, fostering trust within the Fog service ecosystem. Users can rely on the system's integrity. The use of Ethereum smart contracts has enabled quick and secure user authentication. This feature significantly enhances user convenience and accessibility. With distributed data storage on the blockchain, the risk of data loss is minimized. This added reliability further enhances the accessibility of Fog services.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.